Hello guys, welcome back to my YouTube channel. Myself K. Santosh, studying in Sri Venkateswara College of Engineering, Bangalore. Today our topic is the Poisson distribution. The contents of the topic is what is Poisson distribution, understanding the Poisson distribution formula, real-world applications of Poisson distribution, limitations of Poisson distribution versus normal distribution, formulas of Poisson distribution, problems on Poisson distribution, and conclusion. What is Poisson distribution? Poisson distribution is a statistical concept that helps us understand the likelihood of rare events occurring. It was first introduced by a French mathematician called Simon Denis Poisson in the early 1800s. The Poisson distribution is used in the model the number of times an event occurs within a specific time or special interval. The Poisson distribution has many real-world applications, such as predicting the number of customers who will visit a store in a given hour or estimating the number of defects in a manufacturing process. It is also commonly used in healthcare to predict the number of patients who will arrive at a hospital during specific time period. Understanding the Poisson distribution formula. The Poisson distribution formula is a mathematical tool used to model events that occur randomly over time or space. It calculates the probability of a certain number of events occurring within a specific interval of area, given the average rate of occurrence. The formula itself is relatively simple. P of x equals to k is equals to e to the power of minus lambda into lambda to the power of k divided by k factorial, where lambda is the average rate of occurrence and k is the number of events being modeled. To better understanding this formula, let's consider an example. Suppose we are interested in modeling the number of customers who enter a store in a given hour. If we keep that the average rate of customer entry is 10 per hour, we can use the Poisson distribution formula to calculate the probability of a certain number of customers entering the store during that hour. For instance, the probability of exactly 5 customers entering the store would be P of x equals to 5, which is equals to e to the power of minus 10 into 10 to the power of 5 divided by 5 factorial, which is equals to 0.037. Real-world applications of Poisson distribution. In finance, Poisson distribution can be used to model the probability of rare events such as market crashes or extreme prices movements. This information can be used to manage risk and make informed investment decisions. In healthcare, Poisson distribution can be used to model the number of patients arriving at a hospital in a given time period. This information can be used to optimize staffing levels and allocate resources efficiently. Limitations of Poisson distribution. While Poisson distribution can be a useful tool in many scenarios, it is important to understand its limitations. One key limitation is that it assumes events occur independently of each other, which may not always be the case in real-world situations. For example, if we are tracking the number of car accidents on a particular road, the occurrence of one accident may increase the likelihood of another accident happening soon after. Another limitation of Poisson distribution is that it assumes a constant rate of occurrence over time or space. This means that it may not be appropriate to use in situations where the rate of occurrence varies significantly. For example, if we are tracking the number of customers entering a store throughout the day, this may see a higher rate of occurrence during peak level where compared to off-peak hours. Relationship with binomial distribution. The Poisson distribution can be approximated by a binomial distribution when the number of trials is large and the probability of success is small. The approximation occurs when lambda is equals to n, where n is the number of trials and p is the probability of success in each trial. Formulas of Poisson distribution. To find the mean value of the frequency given, that is, m is equals to summation fi xi by summation fi. The Poisson distribution is given by p of x equals to m to the power of x into e to the power of minus m divided by x factorial. Here you can see the formulas which will include in the problems. Till now, we have understood the theory of Poisson distribution and limitations of Poisson distribution and where the Poisson distribution is used. Now, let us take an example of Poisson distribution for better understanding. Fit a Poisson distribution for the following data. X is equal to 0, 1, 2, 3, 4. F is equals to 122, 60, 15, 2, 1. We know that mean formula is M is equals to summation Fi xi by summation Fi. By substituting the values of x and f in the mean formula, we get 0.5. We know that p of x formula is m to the power of x into e to the power of minus m divided by x factorial. First thing we have to check for x equals to 5. Again to the x equals to 1. Again to the x equals to 2 and 3 and 4. For the x equals to 0, by simplifying, we get the answer is 1. For x equals to 1, we get the answer as 0.3032. For x equals to 2, we get the answer as 0.0758. For x equals to 3, we get the value 0.0126. For x equals to 4, we get the value is 1.579. Let us conclude the topic. We have learned the Poisson distribution is a powerful tool for modeling the occurrence of rare events. By understanding its formula and applications in various fields, we can better analyze and predict real-world scenarios. It is important to keep in mind that the limitations of Poisson distribution and to consider other distributions such as normal distribution which operate. However, with its particularity and versatility, Poisson distribution remains a valuable tool in analysis and decision making. Thanks for watching. Those who are not subscribed, please like, share, and subscribe my channel and keep the bell icon on for the future updates.